Hi guys, welcome to this video on circles and using the discriminant. So, to warm up our brains, we've had the weekend off, so warm up, why not write some equations for these graphs. In a minute, so pause the video, in a minute I'm going to show you what I did, or you can check on Desmos, just to make sure it works, or GeoGebra, but just make sure that your center, you know, this actually happens. It's not overlapping or it's not touching in all of these. So just really consider the pictures and think about it in enough detail to get it right. Okay, so hopefully you've had a go. Here are my answers. Yours may be really similar. I've just kept the radius all the same and just made sure that it doesn't touch, or it touches, or it overlaps, for example. So, warmed up, let's have a look. So we're going to jump straight in the deep end here. So we've got a linear graph here, which we're not telling you this, which is at GCSE you would normally have a straight line and a basic circle graph with no transformations on it. We've got a linear graph with an unknown and a circular graph with a transformation. Makes everything harder, but we're also told it crosses at two distinct points. So we're just going to deal with this bit of information first. This comes into the discriminant. So before, you were looking at something like this, like a quadratic, and it had two distinct roots. This time we now have two distinct solutions, and it's going to mean we're going to follow the same pattern. So b squared minus 4ac is going to be greater than, just greater than 0. Here, the second one, you were looking at something like that with one repeated root, and one repeated root means we're going to have a tangent. So this is when b squared minus 4ac is equal to 0. And last but not least, before, when we were looking at the discriminant with no roots, well, here we have a problem of no solutions. So b squared minus 4ac is actually going to be less than 0. Okay, so we're going to merge two topics now to make one slightly harder one. Right, so where two graphs meet, that's simultaneous equations, and when you did that you subbed them in, so let's do that. We've got to sub this in for y. So we've got x minus 3, this would be a big question guys, so brace yourself. So y is kx minus 2, but we've also got to take away a 4, so that's going to be kx minus 6. Okay, the only thing we can do in this situation is expand the brackets, so let's do that. So we've got x squared minus 6x plus 9, and let's just be, I've put these in brackets so I just don't mess up any of my signs. Probably curse myself now and I'll mess it up. So kx times kx is k squared x squared. Now if we consider the outer terms, we're going to have kx multiplied by minus 6, that's minus 6kx, but we're also going to have that on the inner terms, so that's minus 12kx, and the last terms are going to give us 36. Okay, so let's collect all like terms. So what I mean by that is collect the x squareds, collect the x's, and we'll collect the constants. And we're going to put it all on one side because it's a quadratic. So what have we got? We've got x squared plus k squared x squared. We've got minus 6x, so I was meant to write that in pink, but I think we'll get it anyway. Minus 12kx. 9 and 36 is 45, take away 32 is 13. Okay, so everything's on one side, but it's not very pretty, is it? So what we need to do, we can't use this coefficient, sorry, the coefficient's b squared minus 4ac, and because it's two distinct points, we're going to go greater than. We can't use that until it's in that form. So you can see here I've got two x squared terms, so it needs to just be 1. So let's factorise, but this time I'm going to put x squared at the end just to highlight the coefficient of x squared. And I think you'd agree it would be 1 plus k squared. Now it's a bit tricky here with the signs, so I'm going to put this sign first. I'm going to open my bracket and put an x at the end. So this is a 1, right? So that has to be a 6. So that's be minus 6x. I have to put a plus here because if I put a minus, this term would be a positive. So I need to create different signs to create a negative. So that would be 12k. So if you expand this, you've got minus 6 times x, minus 6x, minus times 12k, well that's minus 12k times an x, minus 12kx. So now we have it in the form that we can use my discriminant. Right, let's do that. So b squared, well this is b, so a, b, c. We're going to square this, so I'm going to ignore the negative sign because when I square it's positive. So I'm going to get 36 plus, that's bad form. Let's write it. So we've got 6 plus 12k squared minus 4 times a, 1 plus k squared, lots of 13, is greater than 0. So we've got 36, 144k plus 144k squared. Oop, got ahead of myself there. Okay. Minus 4 lots of 13, so it's 52 lots of this. So minus 52 lots of 1. And we're going to minus 52 lots of k squared. And that is still going to be greater than 0. Okay. Right, so I'll just grab my calculator to do this a bit quicker. So what's 36 take away 52? Minus, no it's not right, what have I done there? Minus 16. We've only got 144k, so let's just put that in there. So we've got 144k squared, but we're taking away 52 of those, and we get 92k squared. Okay, I'm not even going to attempt to factorize this. I'm going to smash it straight into the quadratic formula. Hopefully, it would give me some nice values of k. So we've got 92, 92, 144, and minus 16. Oh, it didn't. I think, guys, what I've done is I've just written this, I've tried to be clever with this question. You can see it's a handwritten one, not an official one. So I've ended up with this. Oh, there's a 4 there. 4 root 26 over 23. And the same, but minus. Great. That is not what I wanted to happen. So these are our critical values because we're solving a quadratic inequality. Right, so if I was to sketch this, what I actually have is this one here, that's about minus, I'm going to write it to 2 sig fig as well, right? That's minus 1.7. Just going to find the other one again. That's actually 0.1. I'll write this to 1 sig fig, so that's actually 0.1. This itself would be a happy quadratic, so we're looking at something that looks like that. And we're interested in where this expression is greater than 0. So please remember, this on this line, this is where the function or the expression is equal, well, not expression, the function is equal to 0. We want where this function here that I've sketched, oh, a slight voice break there, sure you enjoyed that. So this function here is greater than 0, that's above the line, so we're looking at here, oh, that's a rubber, I thought I had a highlighter. So we want this bit here and this bit here. So that is when k is greater than this one. This was the that one. So greater than minus 18 plus 4 root 26 over 23. This would be a nicer number, hopefully, and when k is less than minus 18 minus 4 root 26 over 23. Alright, I'm sorry about that. I must have messed up the question, but you've got the essence. So if they tell you that's 2 distinct roots, you're going to go for this one. 1 repeated root, you're going to go for this one. No roots, you're going to go for this one. Alright, so let's have a look at this one. So this has, again, 2 intersection points. Now, you could obviously just do this one as normal because you've got a straight line and a circle. You could sub it in and actually work them out. But what we can stop a bit earlier than that. So if we sub this in, we're going to have x minus 2 squared plus y minus 1, but that's going to be 2x plus 1. So 2x plus 1 minus 1, that's just 2x. So we're subbing it in simultaneously. Expand the brackets, x squared minus 4x plus 4 plus 4x squared is equal to 9, and we end up with 5x squared minus 4x minus 5. So before we go ahead and solve it to find the 2 points, could we save us some time? The answer is yes. Now, if there are 2 intersection points, which they're telling us there are, and we're just asked to show that, this should be greater than 0. So let's just work out the value of the discriminant. So minus 4 squared minus 4 lots of A, 5 lots of C, minus 5. So we get 16 plus 100, so equals 116. So 116 is greater than 0, therefore intersects at 2 distinct points. That is definitely quicker than actually finding them. Okay, that's all I've got for you. So, like I said, if this set has one repeated, so one distinct intersection, then you're going to go for this one. If they're telling you here that they do not intersect, you're going to do exactly what we've done, but set it up for this one on the right. Okay, so it's all about this line here. That's the line that's going to change. Now, one more thing I will say, if it is a tangent, 1 point, you won't have to do your critical values at this stage because it'd just be equal, you just have to find them. But if it's an inequality, less than or more than, you've got to find your critical values, do your critical value sketch, and then answer the question. Guys, I hope that made sense. Best of luck.